Okay, so we're going to start talking about shifting parabolas and transformations in general. So this is transforming quadratic functions. So when we transform something, then we move it around and we kind of can stretch it in one direction. So let's take a look at how we're going to shift parabolas. I've talked a little bit about it when we're doing vertex form, and most of what we're looking at we can think of as vertex form, and that if it's vertex form, that helps us really see how the basic y equals x squared parabola is being shifted. So let's say f of x is equal to x squared and g of x is equal to x plus 4 squared minus 1, and we can think of g as a translated shifted version of x. Okay, so let me write these down because we're going to talk about the vertex form here in a second. And g of x is equal to x plus 4 squared minus 1. And you'll remember the vertex form is, John likes to give it like this. And I prefer to have it like this, but they're equivalent, you know. And we're just here you're just adding c to both sides to get this one, so they mean the same thing. But this is how we translate something. This is how we move it around. That should be a c. We replace y with y minus something, we replace x with x minus something, and that moves it in the positive direction, C or B. So the first thing we're going to have, ooh, that was ugly. Got to be better than that for translation here. Okay, so the first thing we're going to get is we're going to get y equals x squared here. And you can see that that if we follow this, then our for g of x, our b is going to have to be negative 4. So that means we're going to move 4 in the negative direction for x, and our c is going to equal negative 1. So we're going to move negative 1 in the y direction. So we're going to be moving left and down, and that's what it's asking us. We're going to be moving either up or down. We're going to be moving down by how much? 1 in the we're going to be moving negative 1 on the y-axis, or down 1. And we're going to be moving to the left by 4 units, or we could just say move negative 4 units on the x-axis. Okay. Let me go ahead and get a new screen here. Function g can be thought of as a translated shifted version of f of x. And we know that, again, that vertex form is going to look like this. Y equals a to the x minus b plus c. All right, so I'm going to go ahead and write that back up over here. Plus c, and where b is going to be moving in a positive direction on the x-axis, and c is going to be moving in a positive direction on the y-axis. Here we have moving in a negative direction, negative 5. So our b is equal to -5, and I can see I don't move on the y-axis, so c is equal to 0, and of course our a is 1 here. These are the same shape. You can see we go over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4. Our a is still 1. So our new our new equation for this is going to be y is equal to 1 times x minus -5, or x plus 5, squared, plus 0, or, well, we don't have to write that. So we can write the equation as g of x is equal to x plus 5 quantity squared. Here, the parabola x squared is shifted up by 4 units. So if we're shifted up by 4 units, we know that a is still 1 and b is 0 because we haven't shifted in the x direction, and c is equal to 4. So here we go. We're going to write that. Y is equal to 1, so I'm not going to write the 1. X minus 0, so I'm not going to write that there. Plus 4, or I can write just x squared plus 4. When we think of the vertex form, that's why I love the vertex form so much. It just tells you so much about the parabola. And generally, if you can write something in this transformed kind of format where you've got y minus some number equals some function of x minus something, then things are beautiful. So I'm going to go ahead and write the vertex form again. Y is equal to a times x minus b squared plus c. And this says plus c over here, but just remember we could write it y minus c is equal to this stuff right here. And then that's really, I think, the way we should think about it, because we're shifting y over c, we're shifting x over b, we're shifting y up c, and we're shifting x over b, and then this makes it very clear that we're doing the same thing. And if we have c out over here with a plus, then it's very confusing. Which time do you use minus? Which time do you use plus? So this is just a good thing to remember and a good thing to know for when you do transforming other functions that aren't parabolas. You know, so if we shift a circle, like we'll replace y with y minus c and x with x minus b. We'll do exactly that. Okay, so we've got our y is equal to x squared here, and now we've got y is equal to x minus 9 squared plus 3. So I know that my a over here is 1, and my b over here is 9, and my c is 3. So this means it's the same concavity. It's still going up. Here it means that we're moving in the positive x direction by 9. And here means we're moving in the positive y direction by 3. So positive x direction means right, and positive y direction means up. So that's enough for us to be able to answer this. So we shift this up by 3 and right by 9. And so that's the basics of translating parabolas. And I hope that we did it generally enough so that when you see translating circles or translating other functions, you'll be able to use that, use this when you're doing that kind of translation.